Hey, so welcome back, and this is another daily code problem. So today it's called swap nodes in pairs, and it's another medium level linked list problem. So you're just given a linked list here, and you just want to go through two nodes at a time and swap the order of the nodes. So first you evaluate this first pair of nodes and you swap them. So 1 and 2 becomes 2 then 1. And then you look at the next pair here, 3 and 4, so that it becomes 4 then 3. The only other thing that you have to catch here is that you can't modify the values of the nodes. So you can't just do, say, like, okay, let's just rewrite this node as 2 and then rewrite this node's value as 1. That's not allowed. You actually have to swap the ordering of the nodes. Okay, and so the only other catch here is that you could have like 0 nodes in your list, or you could have like 1 node in the list. So you got to make sure that you only start swapping these nodes if you have a length or at least 2 nodes in your list. So that's kind of the first case you just check here is, okay, if there's no node or there's only 1, so if not head.next, then let's just return the head. And so that handles, okay, if there's no node, just return null. If there's only 1 node, just return the head. Okay, and so from here, what we're going to want to do is we're going to want to keep track of 2 pointers at first, like node 1 and node 2. And so initially, this one's going to be node 1, and then the second node in our list will be node 2. And then kind of we're going to, with each iteration, we're just going to swap these 2 nodes and then increment these pointers. So then node 1 becomes this one, and then node 2 becomes the next one. The other pointer that we want to keep track of is like a previous pointer, and that's because, well, say we're evaluating 3 here. When we swap these nodes, we want to update their pointers. And so when 3 becomes here, we want to update its next pointer, which initially was pointing at 4 here, to then be pointing at like null. And then we want to update the 4 pointer, which used to be pointing to null, to then be pointing to 3 here, like we want it to be. But also, the reason why we want this previous pointer is because then we need the 1 pointer to now be pointing at 4 rather than be pointing at 3. Okay, and so let's go ahead and do that. So first, our first node is going to be equal to the head. Our second node, node 2, is going to be equal to the next node following the head. And then we're also going to have that previous pointer, which initially we want to set as none because, well, we haven't seen anything yet. We haven't visited anything yet, so initially that previous pointer is none. And so we also want to keep track of, because we need to be returning like the head of this list at the end, so you can start at the new head. However, originally the head is 1, but we're going to want to return whatever follows the previous head as the new head. And so at the beginning, we can just set that as well. So we can just say new head is just going to be equal to head.next. And that's basically whatever node 2 begins with will be the new head. So we want to return that new head rather than the old head. Okay, so I hope that makes sense. And now we're going to do kind of the core logic of this, which is swapping these node pairs and then incrementing to the next node pair. And so to do this, we want to do a while loop. And we want to say, okay, while we have I believe, just trying to think here, we'll evaluate this last. I can't think of it at the top of my head, but it's going to be like while we have like n1.next and like n1 and n1.next, I believe, something like that. But usually I fill this in last, especially with linked list problems because you're swapping the pairs a bit. So first thing that we want to do is, okay, if we have a previous, then we want to set the previous.next equal to node 2 rather than it pointing to node 1. And so that would be something like this. So say we swap the order of these, so 2 then 1. And so we want this node, which is now the previous, to first start pointing to 4 because we want it to look like this, right? And so rather than it being pointing to 3, we want to be pointing to what is node 2. And this is node 1. Okay, and so from there, we're going to want to swap the ordering around. So let's kind of keep that same thought where we have node 1 and node 2 here. So why don't we make it so that now this pointer is pointing to node 2. So then let's store what node 2 is pointing to. And so that will be something like node2.next. Node2next is equal to node2.next. And so this is kind of like a temp variable where we just got to store the whatever comes after node 2. And so now we want to update it so that it's now pointing to node 1. And then from here, because we know that node 1 is equal points to node 2, we don't really have to do anything there because, well, right now this is node 1. It's just pointing to node 4. What we want to point it to is this node2.next. So let's do that. So node1.next is equal to node2_next. Great, and that should be all the swapping logic that we need. And so from here, we just want to increment what our node 1 and node 2 are. And so node 1 is then going to be equal to, let's just think here. So node 1 was just swapped, so now it points to its next is now whatever follows it. So let's just do node1.next. And then node 2 is going to be equal to node2.next. Now what about our previous pointer? Oh, not node1.next. So basically like node 2 is being pointed to not the next one, but the next one after that. And then we also want to say, okay, let's update that previous pointer. And so our previous pointer should then be equal to node 1 because it was just swapped. So this was node 1, this is node 2, these were swapped, so now node 1's here. So we want this to be the previous pointer. Okay, and so from here, there is one extra case that we have to consider, and that's an edge case here, edge case. And this is just something that as I was writing the code, I hit that edge case and realized. And that's okay if there's not a node1.next. Let's just break here. And what that is basically like we can have a case where, let's just say it's for an uneven number of nodes. So let's say, just ignore this here. Let's say this is 5, and so it points to null. So this is the tail here. And so what you're going to have is this is node 1, and this is node 2. Or actually, no, we want to, this is node 1, this is node 2, and we have a 5th node here. And so when we want to update these, this is fine, this is valid, where, okay, now this one becomes node 1, and then it can point to like none here, and that will be the new node 2. That's okay in this case because we just want it to swap with none and pop up with this condition here. But we need to break so that we don't want to have an error here. So what if node1.next was none? So this returns none. When we try to do a none.next here, it's going to like terminate the program and like cause an error because it can't do none.next. This is just like exception handling. That might be a better case. Exception handling. Okay, and so other than that, we need to fill in this while condition, which, let's just think here, should be while we have a node 1 and node 2, I believe. So while node 2 then? Yeah, that makes sense. Because you don't want to be swapping, so say if this does point to a none, so node 1 and then node 2 is none, the last thing that you want is, or the last thing you don't want is to swap it so that this becomes none and then try to point none to 4. That's definitely not possible, so you don't want this edge case. So let's try submitting that, and success. So that's today's daily LeetCode problem. So for time and space complexity is going to be just O of 1, since we're just swapping the ordering. We're not cloning anything. We're not using any extra data structures, so that's constant space. And then for time complexity, it's just going to be O of n, where n is the length of the list, because we're just going to iterate through the entire length of the list just once and just swapping the ordering. So yeah, pretty good algorithm, and I hope it helped. Good luck with the rest of your algorithms. Thanks for watching.